Hi, and welcome to Mods. We're keeping you connected to inspiring science with virtual camp discovery, brought to you by Citrix, the museum's official innovation partner.
Stick with us to experience the phenomenon of surface tension. We'll demonstrate the strength of water molecules as they stick together.
Welcome back to Mods. I'm Brady.
I'm Lan.
And we're going to be talking about surface tension today. Now, the surface tension of water occurs when those water molecules bond together.
Like when we bond to make these experiments for your viewing pleasure.
When we all bond together in this educational way, of course, yes. Now, the way that water molecules bond together is very, very strong. Water molecules are very sticky, even where like a drop of rain is held together by the surface tension of water. Now, we're going to demonstrate surface tension in a couple of ways. The first way, Lan is going to attempt to float a paperclip, which by all accounts should sink, right? It's got a weird asymmetrical shape, it's metal. So Lan is going to try to float it on the water. Now, you want to walk us through how you're going to try to do this?
All right, so if you want to try this at home, you want to basically get you a nice big bowl, fill it up with some water. I take two toothpicks, and I put a paper clip on there. And as I'm putting it inside of my water, I'm giving it a slight drop in, and my paper clip slides in like that. So I'm gonna demonstrate that for you now. Give me 1 second. So with science, we have a lot of trial and error. So I'm gonna try it one more time, and this one should work with no problem.
Wow. Okay, so the paperclip is, and you can kind of see those little ripples around it, the surface tension kind of holding it up as the water is being displaced by the paperclip a little bit, just by the weight of the paperclip, which is not much. You see like a little indent in the water.
Just slightly.
And that indent, you can see it's pretty uniform around it. That's the surface tension bonding around it. It kind of reminds me of one of those little bugs you might see crawling across the surface of a lake. Now, I'm going to make this sink with a chemical reaction. I'm going to drop a few drops of soapy water into it. Now, dish soap breaks surface tension. That's basically the main function of dish soap. It breaks the surface tension of water, makes it easy to get grease and food particles and stuff off of whatever you're cleaning. So I'm going to drop it into just a different part of the surface of this water, and we're going to see the surface tension break apart and the paperclip sink right to the bottom.
So it's gonna be like our first paperclip, just sunken on the bottom.
It should be.
Okay.
Yeah, but this is going to be happening not because the first paper clip sank because it was put in at like a little bit of an angle that broke the surface tension.
All right.
This is going to break the surface tension using a chemical reaction of the dish soap.
So before you drop it in, this is gonna break our surface tension instantly with our soapy water.
So it should. That's going to depend on kind of the body of the water. I'm going to, just to demonstrate that, I'm going to drop it kind of far away from the paper clip.
Let's see what happens. Oh, wow. I saw it start to push our paperclip.
Yeah, so just the physical dropping of the soapy water in there created a little bit of a current, but as the soap hit the surface of the water, you can see it's kind of like bubbly and a sheen in there and drop down.
It's pretty cool.
So Lan's going to demonstrate surface tension one more way. Now, this is something we do a lot here, but we're going to take it up a little bit further today. Now,
my favorite part.
This is our upside down flask trick, which you may have seen before, but we're going to try it again with a slightly bigger flask than we normally do this. You ready to show us what's going on here?
Yes, I am. So we got our nice big flask here. We filled it up with some water. We took rubber band and we added a net, basically like you can find on your porch or your patio. So my name tag here, I'm gonna place it over top. This is gonna give me a protective seal as my water forces itself out.
So when Lan flips this over, which you can flip it over, so he's gonna flip it over in one fluid motion. Now what's happened here, you see some air across the top. That air is trapped in there and it has an air pressure that's different than the air pressure in the room. That's giving us one reaction, and you can see his tag is sticking to the bottom there. And as he slides the tag out, we see the water molecules, that surface tension, holding on that screen. And that surface tension is strong enough to hold the rest of the water in the flask. Now this is kind of happening in tandem with the dance of the air pressure up top, being pushed up by the air pressure of the room. But as the water molecules go across that screen, it's strong enough to hold the rest of the water in the flask. And just little punctures like with these toothpicks here, you can see it going up. So the screen is only holding so much. It's just giving a smaller area for the molecules to bond across. And that's going to hold, these little punctures from the toothpick aren't really doing much because the rest of that is there. You can see maybe a drop or two coming out. And that water is going to hold until he breaks that surface tension all around and the water comes pouring out. So that was quite a feat with our 4,000 milliliter Erlenmeyer flask. Hope you learned something about surface tension, and we'll see you next time.
Thank you for joining us for this episode of Virtual Camp Discovery. Special thanks to Citrix, Mod's official innovation partner, for powering this series. Please stay safe and connected with Mods by visiting our social channels at MODSFTL.